Hi students, let's go over lesson 1.2, and our learning targets are, after this lesson you should be able to make and interpret bar charts of categorical data. So we're going to go back over with categorical data, we're going to interpret pie charts, and then we're going to identify what makes some graphs of the categorical data deceptive or tricky. So in these boxes, we've already had kind of like these definitions, but we're just going to go over those again. So a categorical data is when the possible responses fall into categories. Here is a hint that you know that it is categorical data. We can't find the average. We can't find the average. There's no computations, there's no numbers. What are some examples of categorical data? So they might ask you on a survey, or you're filling out your college applications, what is your gender? Because your answer is, you can do ethnicity, might be your age range. Now pay attention, that one is a set of numbers, but it's like a range is over a set of numbers, not just one particular number. Favorite color, or even your hair color. And the answers to all of these are words. Okay, so that is categorical. Let's talk about numerical data. Numerical data is when the possible responses are numerical in nature. How do you know when it is numerical data or numeric values? You can find the average. You can find the average. Another idea is that numerical data can be discrete or, oh, what happened? Sorry. Or continuous. In my examples for discrete and continuous, you've learned this in your previous math class. Discrete is like, how fast can you run the mile? You can run it in 7 minutes and 45 seconds. Or for me, that would be 7 hours and 45 minutes. Continuous would be kind of like if you got a job and they may pay you $8 an hour. It's a rate. It's continuous. And what are some examples of that? I might ask you, what is your weight? I might ask you for your height. How much do you make? I was just talking to a financial advisor. They asked me that. How much is your salary? How old are you is what they asked me. What's the mileage on the car you're buying? How about maybe in this COVID-19, how long is your hair? And just like the word numerical, they are numbers. That's how I would summarize it. They are numbers. All right. So let's talk about the first rule of data analysis or analyzing numbers is to make a picture. And then the second rule of data analysis is to make a picture. And then the third rule of data analysis, what do you think it's going to be? Is make a picture. Make a picture. All right. The following things are important to consider when looking at a graph. Make sure you have a T for title. Number 2, label. On both axes of a line or bar chart. And all sections of a pie chart or pie graph, circle graph. Okay, number 3, source of the data. Where did you get it from? Number 4, what is the key? Or what do your symbols mean to a picture graph? Look under good and bad graphs. We'll talk about that in a second. And then number 5, uniform size of a symbol in a picture graph. Number 6, scale. Does it start with 0? Does it start with a 0? If not, is there a break shown? And you'll see kind of a graph right here. And then this idea of a break, you're going to see, I call it an earthquake. You'll see some lines down there. And then number 7, scales are the numbers equally spaced. Equally spaced. All right, what are our options? Let's talk about categorical. So those are like word-based ones. You can do a bar graph. Or you can do pie charts. Numerical data. You can do histograms. You can do the difference between bar graphs and histograms. Histograms touch for you can have stem plots. Something's going on with my pen today. Dot plots. And a cumulative frequency graph. All right, so there's our categorical and numerical graph options. All right, let's go on down to page 2. Categorical data's graphs. We talked about how there are 2. There are bar graphs. And what do we know about a bar graph? The definition is shows each category as a bar. And the heights of the bars show categories, frequencies, or relative frequencies. We just learned that last section. Frequencies are count, and then relative frequencies are turning them into a fraction decimal. All right, so what are some other characteristics? Bars should be evenly spaced. And have same width. No. Sorry. Evenly spaced with same width and have equal spaces between each bar. All right, the horizontal axis should include the variable names and or possible categories. All right, the vertical axis is going to show us the frequency or relative frequency. And it has a scale that is numeric and starts at 0. All right, let's move on to the second categorical graphs, or taking our categorical data and how do we get a graph for it. These are circle or pie graphs. Did I switch colors? Definition shows each category as a slice of pie. Or think of a pizza. The areas of the slices are proportional to the category frequencies or relative frequencies. Circle and pie graphs are rarely made by hand. So use a computer. All categories are included to make up the whole, and it emphasizes each category's relation to the whole. So you get to compare. How many tardies in the freshman, sophomore, junior, or senior class. All right, so it tells us below 3 examples directions. For each problem below, decide if you can display the data, or whatever they give us, as a bar graph, pie chart, or both. Those are your 3 options. Then create one appropriate graph, more if you want for the data. We'll just be doing one, and make sure to include a title and all necessary labels. All right, so what do we have? Example number 1, if I asked you guys for the eye colors, and you guys submitted those, the eye color of Rebel Statistics students, there are 64 brown, there are 23 blue, there are 36 green, and then there's 5 others. So if you look at that and compare that to what we just did, I could use a bar graph. I could, and you can actually use both for these, because the bar graph shows each category as a bar, right? Brown, blue, green, or other hairs, or eyes, I meant. And then the pie shows in relation to the whole. So let's go ahead and do both. So let's go ahead and create a pie chart. Let's do it over here. So here's my title. I don't know, my pen's going wrong today. Eye color of stat students. So there's my title. And then if you have your circle or pie, and here you're actually converting these into, you're doing actually the previous day's lesson. So if you have 64 brown eyes, and if you actually did a total, you would do something like 64 plus 23, 87, 87, 92, 92 plus 36 gives me 128. So this one would be 64 divided by 128 would give you the 64 would be the frequency, and then the relative frequency is just taking that number and making a percent, and you realize that it would be 50%. That would be the relative. So here I have brown, so each of my categories is represented, and it has a number, 50%. And then you would do the same thing, right? 23 out of 128 for blues, and you'll get 18%. So maybe, okay, so fraction lesson, this is 50%, right? And then half of 50 is 25, so 18% has to be a majority of this, but not all of it. So I'm going to say that this one is blue, 18%. If you ran out of space like I did, you can just say that this one is other at 4%. And this one, this last one, I'm going to write as green at 28%. So this should be more than a quarter. Maybe something like that. Okay, so there is my pie chart. Let's go ahead and do a bar graph, and you can use the same relative frequencies that you would have done. So then same title. Don't do that in your quizzes or tests if I asked you. I'm just kind of going a little bit faster. Okay, so it's not really brown, but there's brown. And then on here, remember you're starting at 0, and then every little tick mark, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65. I should go a little bit higher, 65, and I'm counting by 5s. If I was doing this with paper and pencil, I'd probably use a ruler. And then so again, that should be like 64. And then blues, we have 23. So again, these should be the same width, right? And then you can kind of see that it lines up there. Do you see that? And then what's next? We have green. Green has 36. Right, blue. And then I have others at 5. All right, so that's both my, this is the bar graph in blue, bar graph. And then this one is my pie chart. Questions to answer based on your graph. What percentage of students have blue? Well, we already did the math. And the answer is over here, 18%. How did I get that? I think my pen's dying. 23 divided by the total, 128. I get a fraction, and then take your fraction and multiply it by 100. And then that's how I got the percent. What percent of students have green eyes? So what percent and 28%. You can answer that with a full sentence if I, the percentage of students that have green eyes is 28%. What percent do not have green eyes? So you can either do a couple things. You can add up brown, other, and blue, or you can take the complement, they call this. So 100 minus 28%. And that'll give us an answer of 72%. Let's practice boxing our answers there. Answers. All right, let's go on. And why don't you go ahead and press pause at this moment. And then I want you to go ahead and try examples 2 and 3. And then I'll do those step by step with you in a second. All right, hopefully you just finished examples 2 and 3, so let me go over those with you. If you guys look at example number 2, there's a key word. We haven't talked much about it, but we did take about it in our notes a little bit. Example, zoo animals and their average height. So the big idea there is average height. If you look back at your notes for the one that can only find, they've already given you the average. Let's look back above. And here, because they give you an average, you can't take the averages, and you don't know the total. I don't know if that makes sense or not. There is no total. So pi has a total to it, but there is no total because there's an average. So let's write that on example number 2. So we can only do a bar graph only on this one. The reason why is a pie chart is not appropriate for this data. Why? Because each value represents an average. What's another way of explaining that? You don't know the height of the wallaroos. You don't know how many wallaroos, and then you don't know the percentage of their total heights. All they tell you is their average height. You don't know how many wallaroos. So let's go ahead and create a bar graph. We have our title. Don't know what's wrong with my pen. Just charged it. Average height of animals. Alright, so this is the, what do we call this above? Here is the break that we were talking about. So I'm going to do that here. If you notice that all the animal average heights, none of them are below 88. So you can go ahead and start there. I don't know if that makes sense. So here is my break. It just kind of looks like an earthquake. And then explains why you are now starting at, say, 85. And then maybe you count by whatever you pick, just make it the same. Just count by 15. It's 100, 115, 130, 145. Alright, so let's go ahead and do the wallaroos. Wallaroos go up to 105. And then we got some eagles. Eagles are 88. Eagles. And then we got this animal. I have no idea what it is. Tapir. 97. So with that a little bit below 100. And then I have the zebra, 146. And I forgot to label both axes, so let's do that now. So these are animals. And then over here, this one is height. And then your units of measurement. This is measured in centimeters, and I know that because it tells us centimeters here. All right, let's answer some of these questions. Which animal has the shortest average height? The eagle at 88. Eagle, 88 centimeters. And which one has the tallest? That would be the zebra at 146 centimeters. Why can't we use a pie chart here? We just explained. Because you have averages, you don't have any totals or number of animals. And why is the break helpful there? Don't have to write all numbers up to, we used 85, right? I don't have to write everything from like 0, 15, 30, whatever it is. All right, let's go over this next example. SAV students driving. SAV students driving. Percentage, careful there, percentage of Savannah students with a driver's license by class. So seniors, juniors, sophomores, and freshmen. So here's a question. Do you know how many seniors there are? So a percentage is just like the previous problem. It's just like a average. You don't know how many total. So for remember, we need a total amount to figure out that parts to whole idea. We can even write that here up here. Need total. See if that's better. Oh, I think I fixed this. Maybe. Let's see. So in this case, we're going to have to use a pie chart only. Why? Oh yes, I fixed it. A pie chart is not appropriate. Why? Because this data is not a percentage of all SAV students. What does that mean? If I told you, there's 1,000 students in the class in the school, then you can figure out how many students there are. Because they are percents, do not sum to 100. All right, so again, we can't use a pie chart because you don't know totals. You just have percentages. Percentages and averages are essentially the same thing, but you can't figure out the total. So pie chart, you need total. So let's go ahead and create this. Let's go ahead and do a title, percent of Savannah students. I'll go right faster now. With driver's license by class. And I would spell out all your words there. I'm just kind of abbreviating to go faster for the notes. There you are. And then these are our labeling, our axes. That's our class. And this is our percentage. So you could be marked off if you don't have those. So I have seniors, juniors, sophomores, and the freshmen. And then your percentages. You'll notice that the percentages are all over the place, so I'm not going to do a break in this one. So it's okay if you did something like, I don't know, 10, 20, 30, 40, 50, 60, 70, 80. And let's do seniors. Seniors are at 77. Again, these are bar graphs. These are not histograms. Histograms would have touched. Juniors at 28%. You have sophomores there. They're at 6%. And then our freshmen at 2%. Okay. All right. Let's answer these questions. Which is greater? Seniors driving. So seniors were at 77%. Or the other three classes combined. So if you did 28 plus 6 plus 2, you would get 36%. So which one is greater? 36 or 77? The answer would be 77. So which is greater? The answer is seniors. Why can't we use the pie chart? We just explained that up here. Okay. All right. Good or bad graph? So we need to look at these graphs here and determine if it's a good or bad one. And if you look at it, these are called pictographs. Pictographs from above. Why is it called a pictograph? Because it is a picture, and the picture represents the man. And this one looks so big, and then this one over here looks so small. But the difference is there is only 14%. So I would say that this one is a bad graph. Why? In 1964, the doctor looks so much bigger that we look at the pictures and not the number of doctors. Maybe this person here in this shrinking family doctor, they're saying that, you know what, hey, there is less doctors for family practice, and therefore you might make an argument that healthcare is getting worse, right? From 1964 to 1990. So you can use that. So that's a bad graph. Let's go this way. All right, bar graph shows the results of a survey taken at Brookfield Middle School. So let's go ahead and answer this. Which subject appears to be twice as popular as science? Well, this is science. The word twice means times two. So which one is twice as big? If you put two of these stacked together, that would be social studies. How is this graph misleading? Well, hopefully you can put your finger on it. We just talked about it. Your bar graph should start at 0. So why the vertical starts at 30. Now, it may have been appropriate to do the break there, if you're saying there's no other numbers. All right, how can you change the graph so it's not misleading? Create a new graph. So we'll just quickly make one. Math, social science, and science. And then I'm going to start at 0. So this is 0, 10, 20, 30, 40, 50, and that goes all the way up to 70, 60, and 70. So if I do math, that goes to, say, 55. Social science goes to 70. And then you're going to say that science goes to maybe like, I don't know, 48. Then you might say it's not it's not twice as much, right? Social science is not way better than science. Maybe it's not as twice as much as it was before. All right. 6A. Make a line graph giving the impression that there may have been many new clients since the first television ad first appeared. So let's go ahead and just create. And it's all about your scales. Let's just say you're some of you guys are going into business, and you really want to show that there are so much more people, right? So maybe you have it up here by 44, and maybe you have 35, and then you have January, February, March, April, May, and June. And then from here, a line graph is just kind of putting a dot. So 35, and then 38, 40, 42, and 44. And you're trying to show that, wow, this is like really going up, really big time, right? But if you just change your graph, make a line graph that now indicates that there's small increases. So, well, what do you do in the last problem? They didn't do that part. So let's say you do put the break in there, and instead of there, you just start at 30, 35, oops, 35, 40, and 45. And same thing, January, February, March, April, May, and June, and this is the number of clients. And maybe you're trying to argue that, you know what, your friend over there didn't really do such a good job. So then January is 35, 38, maybe 40, 42, 43, and 44. and then you're saying that it's more flat. Okay, so statistics can, same data, the big idea is here is big data, same data, you can get two representations. You can mislead people to think that there was no growth, or maybe this graph, if we kind of move up the 44 a little bit higher, we can show that there was more. And almost done there. Which graph more fairly represents the data? I would say the second graph. Why would someone want to exaggerate the number of new clients? Maybe a salesman or woman, salesperson, might want to show that she is doing a good job by showing a large increase in clients. Hey, don't fire me, because this large increase in clients, the vertical distance, does that make sense? This is great. And then, like, you know, your enemy over there is saying, your increase is just a little bit from here to there. So showing that growth could be misleading. All right, so that just summarizes what we just finished there. Bad and good graphs and a summary of those 5 graphs. Good luck, guys.